So yesterday we were talking about this, right? So what we discussed, Zn, what are the elements of Zn, right? So what is Zn? Zn is a set of equivalence classes modulo n with respect to congruence relation, right? And we can add two classes, and what is the addition of two classes is a new class, right, whose representative is the sum of representatives of these two classes. That means if you want to add class A and class of B, then it is a new class C. But what is the class of C? As class of A and A plus B, right? Class of A plus B is different from class of A and class of B. For example, class of 1 is this and class of 2. And what is the class of 1 plus 2 is 3, which is a different class, right? Similarly, we can multiply two classes. It is a new class, and what is the representative? Is representative is product of representatives of these two classes. So this is how we define addition and multiplication on this. And if your addition and multiplication, you can do lots of things with this, right? So that we can write multiplication table. So this gives all possible multiplications, right? Now, and I gave you exercise. We repeat all these things for Z6, Z7, Z3, Z2, right? So, what is Z2? Can you tell me what are the elements of Z2?
Zero class.
0 bar, 1 bar.
Zero bar, one bar. One bar.
So there are only two classes, right? And Z3, 0 bar, 1 bar.
0 bar, 1 bar, and 2 bar.
Okay, so now Z6 is 0 bar, 1 bar, 2 bar,
2 bar, 3 bar, 4 bar, 5 bar.
5 bar.
Now if you write the multiplication table, right? So what is the difference than other our usual algebra? Because if you observe here in Z6, 3 bar plus 3 bar. What is 3 bar plus 3 bar?
0 bar.
0 bar.
0 bar.
0 bar.
Right. And this is unusual thing, right? It is unusual means what? Ki the numbers, an element added with the same element gives identity. Right. This is not happening in general, right? Because if you add two real numbers, or x plus x is not 0 if number is not 0. So, and 3 bar is not 0 bar. So 3 bar is not 0 bar. So 0 bar is additive identity. Additive identity of Z6, and 1 bar is multiplicative of Z6, right? Same thing is true in Zn also, right? So 0 bar is additive identity, means if you add any A bar with 0 bar, it gives us A bar. So 0 bar is additive identity, and A bar multiplied with 1 bar is again A bar. So because we know that the addition of two classes is just add their representatives and their its class, right? So that is how we define the A bar plus B bar is A plus B, whatever choose just representative of these classes, add them, and whatever is new element, its class is the addition of these two classes. That is what we say A plus B is congruent to C, right? C is a representative. So anyway, so these are this 0 bar is a additive identity, 1 bar is a multiplicative identity, and 3 bar plus 3 bar is a 0 bar, right? So 3 bar plus 3 bar is 0 bar means what? 3 bar is additive
Is
inverse
multi.
of additive inverse, right?
Yes.
3 bar is additive inverse of itself, right? So what is additive inverse of 3 bar? Is 3 bar, because 3 bar plus 3 bar is 0 bar, right? So 3 bar is an additive inverse of itself. Is it clear?
Yes, sir.
Fine.
Yes,
Now
sir.
2 bar plus 4 bar is
0 bar.
0 bar, and therefore 2 bar is additive inverse of
4
2
bar.
bar is additive inverse of
4 bar.
4 bar.
4 bar. And 4
and
bar
4
is
bar is
additive
additive,
inverse of 2 bar.
right? So if you write down the addition table as we did yesterday, then you can get clear idea which one is additive inverse of which element and so on. Right, this is one observation you can have. 1 bar plus 5 bar is 0 bar. So therefore 1 bar is additive inverse of 5 bar and 5 bar is additive inverse of 1 bar and so on. Now, if you see this, what is 1 bar into 3 bar is 3 bar, right? 1 bar into 3 bar is 3 bar. 1 bar into 1 bar is 1 bar, multiplicative identity, right? Now, what is 4 bar into 4 bar?
2 bar.
Is
4.
4 bar, right? Am I right?
4 bar.
That
Yes.
means
4 bar.
4 bar square is 4 bar in this case. And this is very interesting. 4 bar square is 4 bar. So the square of this element is itself. But when this happens in general in real numbers, when we say in real numbers x square is equal to x, when it happens either x is equal to 1 or minus 1. There are two possibilities, correct? X, no, x square. When this happens in real numbers
X equals to 1.
or x is equal to 0, right? So similarly, x square is equal to x happens if in this case x is 1 or x is equal to 4. So x square is equal to x, the solution of x square is equal to x in Z6, right? What are the solutions of this equation in Z6 are, what are the solutions? X square is equal to x,
Bar.
X is equal to 1 bar or 4 bar.
right? X is equal to 1 bar and 4 bar. So these are two solutions for this equation in Z6. Similarly, what are the solutions of this equation in real numbers? So 0 and 1, right? So the you can see similar kind of things. Now, what is one more interesting thing is, what is 5 bar into 5 bar? That means 5 bar square in Z6.
1 bar.
1 bar.
1 bar.
1 bar. 1 bar.
Right. So that means what is multiplicative inverse of 5 bar?
5 bar.
Itself 5.
So
5 bar.
5 bar is
Bar.
multiplicative inverse of itself. Of in Z6, we are talking about Z6, right? So 6 is special in this case, not in general. In Z5 or in Z10, the things are different, right? In Z6, 5 bar is a multiplicative inverse of itself. Now, 2 bar into 3 bar,
0 bar.
0
0 bar.
bar.
0 bar.
Yes, 0 bar.
2 bar is not 0 and 3 bar is also not 0. That means two elements are non-zero, but their product is 0. But this is not possible in real numbers. When I say x into y is 0 in real numbers, then x is 0 or y is 0 in real numbers. Right, so this is a difference. You understand this? See, there is a difference between real numbers and this structure Z6. Right? This is in Z6. In Z6, 2 bar into 3 bar is 0 bar, but none of them is 0 element. So, or 0 means additive identity. So, none of them is additive identity, but product is additive identity. So, this is happening in this situation, in this case. But this is not possible in Z5. If you observe the multiplication table of Z5, you just go back to the multiplication table of Z5. Here, multiplication of Z5, where where 0 occurs, in first row and first column. Nowhere else, right? So 0 occurs in the position where one of the factor is 0. 0 bar is 0. 0 bar into 1 bar is 0. But at other places there is no 0. That means if factors are non-zero, then we cannot get 0 bar. This is a something special about 5. But what happens in Z6 if you have written the multiplication table of Z6, right? Multiplication table of Z6, and you check this 0 bar, 1 bar and so bar, and you find that there are zeros where the number the two factors are non-zero, but you can get 0. So you just write down multiplication table and see this. This is something special about 6 and something special about 5 also, because in table of 5 it is not happening. 0 occurs only if one of the factor is 0 or 0 bar. So that is about 5, and in Z6 if factors are not 0, then also 0 occurs. Correct. And what is the speciality? Yes.
In solution, sir, can you
Yes.
scroll down?
Which?
Solution x square is equals to x. In Z6, the solutions are x is equals to 1 bar and 4 bar.
0 bar is also solution, right?
Sir, as we take 3 bar into 3 bar, it get 3 bar.
Yes,
Yes,
sir.
3
Means
bar. Very good. 3 bar is also solution. What is one more solution? Is 2 bar solution?
no,
No.
sir. No, sir.
So
No, sir.
there are 4 solutions, right?
Yes.
Right. And so these are the something strange properties, and these properties have significance. This has lots of applications in computer science or anywhere, means coding theory, right? Cryptography. So where you come across
Sir,
crypto? Yes.
sir, in Z6, what is
Uh,
the multiplicative inverse of 1, 2, 3, and 4?
yeah. Let us see this. That is what I am going to the next point. So now, what is multiplicative inverse of 1 bar?
1 bar.
1 bar, because 1 bar into 1 bar is 1 bar. Therefore, 1 bar is multiplicative
1 bar.
inverse of 1 bar. So that is clear. Now, 5 bar into 5 bar is 1 bar. Therefore, 5 bar is multiplicative inverse of 5 bar. That is also clear. Right? Now, what remains now? So 0 bar is no question about multiplicative inverse, because 0 bar is a 0 element. When we talk about multiplicative inverse, if it is non-zero, so 0 bar is a 0 element of that set or additive identity. So 2 bar, what is the multiplicative inverse of 2 bar? So question is, does 2 bar have possesses multiplicative inverse in Z6, right? And question is easy, you just check, combine 2 bar with any other element, can you get 1?
No,
Right?
sir.
Right? So
No,
you
sir.
just try
Yes,
2
sir.
bar with 1, 2 bar with 2 bar, 2 bar with 3 bar, right? 2 bar with 4 bar, and 2 bar with 5 bar. So you try all possibilities. and we will not get 1, right? So answer is no.
There is nothing.
So 2 bar has no multiplicative inverse, therefore does not have multiplicative inverse in Z6. Similarly, I will repeat same question for 3 bar in Z6. Right? Does 3 bar possesses multiplicative inverse in Z6? Same question. What is answer?
No.
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 Answer is no. Now I will repeat same question. Does 4 bar possesses multiplicative inverse in Z6?
No.
Right?
No,
And
sir.
answer is no. So, okay, this is one thing. Now let us consider Z5. Let us consider now Z5, and I will repeat question. Does 1 bar possesses multiplicative inverse in Z5? Right? So the question is very simple. Does 1 bar possesses multiplicative inverse in Z5?
Yes, sir.
Yes.
1 bar. 1 bar.
Yes.
Right. So 1 bar itself is multiplicative. My next question. Does 2 bar possesses multiplicative inverse in Z5?
Yes, sir. 3
No,
bar.
No, sir. No.
Because 2
Yes,
bar
sir.
in 2 bar
Yes, sir.
into
3 bar.
3 bar. 2 bar into 3 bar is 1 bar. So 3 bar is multiplicative inverse in Z5. That we have already. And it is very easy from this multiplication table. What is this is multiplication 2 bar into 3 bar, right? Where 1 occurs in the row of 2? Yes. Does 1 occurs? Yes. So with column of 3. Intersection of row of 3 with column of 3. So 1 bar occurs. That means 2 bar into 3 bar is 1 bar. So 3 bar. What about 3 bar? So 3 bar into 2 bar is 1 bar. In this here 1 occurs. What about 4? 4 bar into 4 bar is 1 bar. So 4 bar is is a multiplicative inverse of 4 bar. Right? So now what is the question? Does 2 bar 3 bar possesses multiplicative inverse? So yes,
Yes, sir.
right? And does 4 bar possesses multiplicative inverse in Z5? Again answer is
Yes.
yes. So what is the
Yes.
conclusion? Every non-zero element in Z5 except 0 we tried for every, right? Except 0 we tried for every. So thus from multiplication table also it is clear. Every non-zero non-zero. Zero means what? In Z5 or Zn, what do I mean to say that zero means 0 bar, right? Right? The class of 0. Every non-zero element in Z5 possesses a multiplicative inverse. Right? And this is similar to real numbers. Every non-zero real number possesses, is it similar to R? Right? So is it similar to R? Real numbers. Every non-zero real number possesses multiplicative inverse, right? But this is not happening in case of Z6. But in Z6, there are non-zero for which there is no multiplicative inverse. inverse in Z6. Right? So there is no multiplicative inverse in Z6. And if you have tried the table of I gave you yesterday Z7 and multiplication table of Z7, right? Those who have did this, those who did this exercise, they can observe that multiplication table of Z7. And what is the structure of multiplication table of Z7? Right? It is similar to Z5, right? Similar in the sense that every non-zero element has multiplicative inverse. In Z3 also same thing is true. Z2 also that is true. And therefore, what you can say, what is the difference between 5 and 6 or Z5 and Z6, Z7? From this, what you can observe, if you observe the table of 7, Z7, table of Z3, Z5, Z6, what can be the general statement? What can be the general statement? Can you tell me?
Z2n plus 1 possesses all the multiplicative inverses.
Z
2n plus 1 odd numbers.
odd numbers. What about Z15? Think about Z15, right? Okay, what are the elements of Z15? 0 bar, 1 bar,
0
5 bar,
bar
5
to 14 bar.
Up to 14.
14 bar, right? Now, what is 3 bar into 5 bar in Z15?
0 bar.
0 bar.
0 bar.
0 bar.
0 bar. And thus 3 bar has multiplicative inverse?
No.
No.
Oh,
No.
thus 3 bar possesses multiplicative inverse. In Z15, right? So answer is no. So why answer is no? Suppose A bar is multiplicative inverse. Suppose multiplicative of 3 bar in Z15. Suppose there is a multiplicative inverse which is A bar of 3. Then A bar into 3 bar would be 1 bar.
1 bar.
Right, now I will multiply both sides by what? 5 bar. A bar into 3 bar into 5 bar. I will multiply both sides by 5 bar. And this multiplication is clearly well defined because I am just multiplying by same class. Right? 1 bar into 5 bar. But what is the right hand side now? 1 bar into 5 bar is?
0 bar.
No, in Z.
No, 5 bar.
Sorry. 5 bar.
5 bar. 5 bar.
Sorry, Z15 5 bar is 5 bar, right? So, and what is left hand side? A bar into 3
0
bar
bar.
into 5 bar is
0 bar
equal,
into 1 bar.
right?
0 bar.
Therefore, and this is A bar into 0 bar is equal to 5 bar. This implies 5 bar is equal to 0 bar in Z15, which is not true. Which is contradiction. Right, so immediately we see that if 3 bar has a multiplicative inverse, we will get a contradiction. Right, and therefore 3 bar, and you check it manually also. You combine 3 bar with all other possible elements, you will not get 1 bar. 3 bar do not have multiplicative inverse, right? And therefore odd is not the right observation. So, right?
Sir, what is about prime number?
Yes, this is the main crux. The prime number is most important word. So what is the conclusion? Or at present we can say it is a conjecture for our conjecture actually, but what is the meaning of conjecture? People prove something, people verify some result by various examples and there is no counter example, then we can say that this result supposed to be true in general but not proved, but we can say conjecture or it is already proved but you can prove it. So in Zn, every non-zero element possesses an multiplicative inverse if and only if n is a prime number. This is if and only if. So in Zn, every non-zero element possesses a multiplicative inverse if and only if n is a prime. If and only if means what? Every non-zero element has a multiplicative inverse, then n is a prime. If n is a prime, then every non-zero element has a multiplicative inverse. And if that means if n is not prime, then this condition fails. So logically, P if and only if Q means what? Means P implies Q and Q implies P means not Q implies not P and not P implies not Q. Right? Means negation of P if and only if negation of Q. So when we say we have two statements and if and only if, it is equivalent to saying that the negation is also if and only if. And therefore if n is not prime, then this fails. That means some non-zero element in Zn may not have multiplicative inverse, and that is what happening in Z6. Right? So 6 is not prime. So 6 is not prime, right? And therefore some non-zero element do not have multiplicative inverse. Is it clear? We'll not prove this theorem right now because we'll prove it later on. But this idea you should understand. Then again, a question you can ask yourself: if n is not prime number, that is n is a composite number. Composite number, then which elements in Zn possesses multiplicative inverses and which do not? The question is clear. This question immediately should come in your mind. If n is composite, then the condition fails that every element, non-zero element has multiplicative inverse. Suppose n is not prime number, that means n is a composite number. In Zn, which element possesses multiplicative inverse and which do not possess? Is it clear? Question is clear?
Yes.
Yes.
Oh,
Yes, sir.
now let us observe Z6, 0 bar, 1 bar, 2 bar, 3 bar, 4 bar and 5 bar. The which elements have multiplicative inverse?
1, 2, 3.
1, 2, 3, 5.
3, 5.
Okay, so the set of elements in Z6 having
1 and 5.
multiplicative inverses.
1 and 5.
I will denote this by Z6 cross, right? So say elements having set of elements having multiplicative inverse, and what are 1 bar and 5 bar? Only two, right?
5 bar. Yes.
Now elements in Z6 do not have multiplicative inverse. And what is that set? 0 bar. Okay,
Bar.
forget about 0. 0 is not
3
special
bar
for us.
and 4 bar.
We
2
are,
bar,
3,
3
4
bar, 4
we
bar.
are interested in 2 bar, 3 bar and 4 bar.
and 4 bar.
These are the elements we do not have multiplicative. 0 is not the problem because we are not worried about 0. 0 is very exceptional case. Right. Okay, now you observe these two sets. I have separated Z6 and Z6 into two parts. ZX, Z6 cross and Z6. The elements do not have multiplicative inverse. Now, can you observe this and can you make conjecture? Conjecture means can you make the general statement?
All the odd numbers have their multiplicative inverse.
There is no question about odd and even, right? In Z6, in Z5, Z5, 4 is not odd number, but still it has multiplicative inverse. Yes.
All the prime numbers.
Right. In Z5, 4 is a 4 bar is not prime.
Also,
Right. 4 bar is not odd. Still 4 bar has multiplicative inverse in Z5. Am I right?
Because it is a multiple of a prime factor of 6 of Z6.
You are close to the answer, right? So what is observation here? Observation. What is observation? GCD of 1 with 6 is 1. GCD of 1 with 5 is also 1. Right? And GCD of 2 with 6 is not 1. GCD of 3 with 6 is also not 1 or greater than 1 basically. GCD of 6 with 4 is also not 1. This is what the common thing among these elements and these elements, right? What is the common thing about ZX cross? Common thing among elements in ZX cross, right? All of them, the representatives have GCD. For example, if I select because Z5 bar is 5 bar is same as in Z6, 5 bar is same as 11 bar, right? Am I right? In Z6, 5 bar is same as 11 bar.
Yes.
And GCD of 11 with 6, GCD of 11 with 6 is also 1. Therefore, no matter what representative you select. And therefore, what is a common thing among these classes in Z6 star? You take any representative of class of 1, you take any representative of class of 5, their GCD with 6, right? This is the observation. And here in the element not have multiplicative inverse, you take any element of 2 bar, its GCD with 6 is not 1 or greater than 1. GCD of 3 with 6 is greater than 1, GCD of 4. So this is the main observation. Is it clear? The observation is clear?
Yes.
Yes, sir.
Okay, now can Can you make some general theorem or statement? Can you make some general statement, which will be a big statement? Right, so this is a particular case and I want to make a general key, which will be suitable in any situation, whatever n doesn't matter. Here I am talking about n is equal to 6, right? But I want to make a statement which is independent of n. Whatever n to you choose, Zn, look at Zn, and that statement is fits to that Zn, right? I make the general statement.
Sir, GCD meaning?
Greatest common
With
divisor.
GCD 1.
Greatest common divisor. You don't know GCD, right? You know what is GCD
Okay, sir. Thank you.
of m and n is greatest common divisor of m and n. For example, what is GCD of 10 and 2 is 2, right? And which you did in 5th standard. GCD of 12 and 6 is 6, right? So you can understand GCD. So I am talking about general statement. Which elements possesses multiplicative inverse and which element do not possess it. So
The elements with GCD is equal to 1.
so in Zn, now I want to make for general n, Zn,
X
A
bar
bar
will have
possesses multiplicative inverse
With GCD 1.
inverse in Zn if and only if GCD of the representative with n is 1, right? GCD of representative, whatever representative you select with n is 1. If and only if. If and only if means what? As we discussed before, when we say if and only if, then negation. That means element do not have multiplicative inverse. That means GCD is not 1, right? That is, this statement is equivalent to A bar do not have multiplicative inverse if and only if GCD of A with n is greater than 1, right? Not 1 means greater than 1, because GCD is always non-negative quantity, so that we will discuss later on. But right now we are interested only this, so we'll not try to prove this right now. We'll prove maybe later on, right? But this is what you should observe, right? Okay, fine. So this is clear.
Sir,
Yes.
can you please scroll a bit? Yeah. Sir, GCD of 5 and 6 is also not 1, right? In this observation.
Oh, I wanted to say 5 or 6. 5 or 6. GCD of 5 or 6 is 1, right? Correct. Am I right? GCD of
Yes,
5
sir,
and
understood.
right, and therefore 5 has multiplicative inverse. So therefore those elements having GCD with 1, they have multiplicative inverse. Now in the view of these two theorems, which theorems we have stated now? Every non-zero element in Zn has a multiplicative inverse if and only if n is prime. That means your n is prime, then you choose any non-zero element in Zn, it has multiplicative. What second theorem says? Whatever is n, the element has multiplicative inverse if and only if the GCD of representative with n is 1. So this is now Z. Let us think about Z7. What is Z7? 0 bar, 1
Sir,
bar, 2 bar. Yes.
so in this theorem, n can be composite.
Yes. I am not saying prime, right? You choose any
Yes.
Zn of your choice. In Zn, which element possesses multiplicative unions and which do not?
Okay, sir.
That is the question. Right. Now in Z7, which elements in Z7 possesses multiplicative inverses? You understand?
All non-zero.
All
All
non-zero.
yes, all non-zero elements are multiplicative inverse.
And check it. Right? So you check it, all non-zero element possesses multiplicative inverses. Now Z10 for example, 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, 5 bar, 6 bar, 7 bar, 8 bar, 9 bar. 1 bar I can denote by 11 bar also. Remember this. I am, for simplicity, I am using this representatives. Otherwise, you can use any representative. Anyway, now which element possesses multiplicative? Immediately tell me now.
1379.
1 bar, 3 bar, 7 bar, and 9 bar. These element possesses multiplicative inverses. You check it. Right? So you need to check it. So therefore, what is Z10 cross set? Multiplicative elements having multiplicative inverse. Right? So this is Z10 cross. And which element do not possess multiplicative inverse? The remaining elements. Right? 2 bar, 0 bar, 4 bar, 6 bar, 8 bar. So these elements do not possess multiplicative inverses. So this is clear. And now next question is find their multiplicative inverses. Right. So find multiplication. So 1 bar, 3 bar, 7 bar, 9 bar possesses multiplicative inverses. Now find multiplicative inverse of 1 bar. Find multiplicative inverse of 3 bar. Find multiplicative inverse of 7 bar. Find multiplicative inverse of 9 bar. Now, and one more simple observation, multiplicative inverse of 3 bar is among these 4 only, right? It cannot be outside this. Otherwise, if suppose multiplicative inverse of 3 bar is some 8 bar, then 8 bar has multiplicative inverse which is 3 bar, which is not possible. Right. Therefore, if multiplicative inverse of 3 bar is there, so it is among these 4 numbers. And which one is it? 7 bar, right? 3 bar into 7 bar is 1 bar, because 3 into 7 is 21. 3 into 7 is 21, and 21 is congruent to 1 modulo 10. Am I right? Is this clear? Okay, now what is multiplicative inverse of 9 bar?
9 bar itself.
9 bar itself, because 9 into 9 is 81, and 81 is congruent to 1 modulo 10. So you check this. This is a very interesting thing, and this thing has a lot is a significance in very practical applications. So later on you may understand it. So, and if you want to read more about it, you can read a book, Elementary Number Theory. by David Burton. There are many other books also, Niven and Zuckerman and so on, but you should read this book because these ideas everyone should know. As a science student, everyone should know these ideas. Or if you apply application of mathematics, you need these ideas. For example, coding theory or cryptography. So where we use coding theory or cryptography, so you have a password, email password or bank account password. So you have lots of passwords. How these passwords are decoded or encoded. WhatsApp says that your message will be end-to-end encrypted. Right? WhatsApp says that your message is end-to-end encrypted. Encrypted means what? Whatever your message is transformed into some another string, and that string is transferred, and when receiver receives that message, then again it is encrypted in original string. And how it is done? So this kind of mathematics is involved, right? And how it is involved, and for that you need to do some more mathematics. Is it clear?
So,
Yes.
how
Yes.
can we
Yes.
calculate the which elements have multiplicative inverse? Means GCD is right way, but someone says it rapidly. But means how can it calculate so rapidly?
What? Multiplicative inverse.
It means which elements have multiplicative inverse.
GCD. This is the only technique. GCD. GCD. Right.
Okay. Among that element means what technique is used that which elements have GCD is equal to 1.
That means
Means
you
I
want to
didn't.
identify. You want to say that how to identify elements having GCD is 1.
Yes.
So that is just identify means what? Those elements do not have common factor with n. Those elements those representatives which do not have common factor. So this is a basic idea, right? And then if you work with the larger, like suppose you want to work with Z 2020, which is a very big set, right? And then what are the numbers or what are the elements which are which have GCD 1 with? So let me make some definition. So let AB belongs to Z, then A is relatively prime with B if GCD of A with B is 1. So relatively prime. So A is relatively prime with B if their GCD is 1. So there is no common factor except 1. Right? There is no common factor greater than 1, then they are relatively prime. So how will you identify the elements which are relatively prime? For that you can have some smart techniques, but that techniques for large numbers, for small numbers it is very trivial situation because you just observe the factors and it is very easy to observe the factors, right? Observe the factors. So
Yes.
you take any element a bar in Z 2020 and you know what are the factors of 2020 and you know the right. If I take a bar belongs to Z 2020, right, then you know what are the factors of 2020, you know factors of A, and if there is a common factor at all, then you can say that they are not relatively prime. If there is no common factor at all, then they are relatively prime, so that you can observe. For large number, you have some techniques in number theory, and for that you should read such books, elementary number theory,
Yes, sir.
right? But one question you can ask in, for example, uh, suppose I take 17 bar in Z 2020, right? Then what is multiplicative inverse of 17 bar in Z2020? So this could be a little bit difficult question. Little bit difficult, not really, because Z2020 has how many elements?
2020.
2020.
120 elements. And Z17 bar definitely possesses multiplicity inverse, because GCD of 17 with 2020 is 1, because 17 itself is a prime number, so no factor other than 1. So clearly 17 bar has multiplicity inverse in Z2020, but you have to check
2013.
what is
2013. Sorry, 2003.
whatever it, but okay, so in some cases you may easily recognize it, but if your number is larger, then how to recognize the multiplicity inverse? And you cannot check one by one, right? It's a tedious
Yes.
job. So therefore there is a smart technique. So what is a smart technique? I will think about Z6, for example. Not Z6. Okay, Z6. So 5 bar has a multiplicity inverse, right? In Z6, 5 bar has multiplicity inverse. Now, because GCD of 5 and 6 is 1, and if uh, uh, this is a statement or note, if GCD of M and N is 1, or GCD of M and N is D, then there are integers A and B such that AM plus BN is equal to D. This is again a theorem basically, but right now it is not convenient to prove it. Probably if we discuss about these things later on, we'll try to prove this such kind of things, or you can find proof of these things in this book, Elementary Number Theory. So if GCD of M and N is D, then certainly I can express this M and N combination. I can express GCD as a combination of these numbers. So for example, what is GCD of 2 and 6? GCD of
Does not equal to
GCD of 2 and 6 is 2.
Does not.
Now can I write 2 as a combination of A times 2 plus B times 6? What is A and what is B? Is it possible to express 2 as a combination of 2 and 6? Right? Can you tell me such numbers A and B in this particular case?
minus 2 and 1.
1 and 0.
Yeah, minus 2 times 2, right? Plus minus minus 1 times 6. Am I right? No, what I want? I want plus 2, right?
So minus 2 and 1.
Right. 2 times minus 2 plus 1 times 6, right? So minus 2 times 2 plus 1 times 6. Am I right? And what is A in this case? A is minus 2 and B is 1. So I can express GCD, right? What was my GCD? GCD as a combination of these two given numbers. Correct? Now what is GCD of 2 and 3 is 1. Now how can I express 1 as combination of 2 and 3? So 1 is equal to minus 1 times 2 plus 1 times 3, right? And so what is A is minus 1 and B is 1. certainly I can express 1 as a combination of these two numbers. Is it clear?
Yes, sir.
And basically this
Yes,
is
sir.
a general idea. For any situation this is true, and we are verifying it for particular. Okay. And then using this idea, you can easily find the multiplicative inverse. Right? You can
Yes,
find
sir.
multiplicative inverse. So how you think about it? Probably next time we'll discuss it, and we will do something about equivalence relations. Right? Because Zn, this congruence relation is a very special relation. It has lots of applications. That's why we are spending lots of time on this. Right? So this is very interesting thing. So next time we'll spend some time on this, and then we'll go to the something about equivalence relations, right? So I think we should stop here. Any doubt, any difficulty?
No, sir.